Hello, algebra students. Today we're going to be solving quadratics by factoring, and I'm going to introduce you to a new form called the vertex form. So let's look at the vertex form first. And it's just another way to write a quadratic equation. And remember what the standard form looks like. The standard form looks like this: y equals ax squared plus bx plus c. Now, what do I know from the standard form? Well, remember, I can tell if it's an upward or downward parabola by looking at the value of a. All right, and if a is positive, it's going to be an upward parabola. If a is negative, it's going to be a downward parabola. I can also tell what the y-intercept is. The y-intercept is going to be c. And those are the things I can tell from standard form. Now I can easily find the axis of symmetry and the vertex, but I have to do a little work to do that. Vertex form, what it does for me is I'm able to see the axis of symmetry and the vertex at a glance. So here it is: y equals a times the quantity of x minus h, quantity squared, plus k. I still know what a is, so I still know if it's an upward or downward parabola. All right, but also I know that h and k are my vertex, hence the name vertex form. So h and k are the vertex. So I not only know the vertex, but I'm also going to know the axis of symmetry, because h is the x value, and that's my axis of symmetry, because my vertex is always on my axis of symmetry. Now I can also, if I am given the vertex form, I can turn it back into the standard form by doing a little bit of multiplication. Remember though that x minus h, that quantity squared, is x minus h times x minus h. And so I would have to FOIL that part. So let's look at this. Here we have this, and I need to recognize that this equation is in vertex form. Okay, so what do I know? Well, I know that a is going to be equal to 1. All right, because it's a ninja 1 there. So a is 1, and that means that that is going to be an upward parabola. All right, what else do I know? Well, I know that my vertex is hk, which means in this case it's going to be 2, 3. All right, and I also know, because the x value, or the h, of the vertex is 2, so my axis of symmetry is going to be at 2. Now, I need to complete the graphing the parabola, so I'm going to go ahead and, how did I do it before? Well, I chose a value. I chose a value, any value I want to use. I chose a value for x and plugged it in. I can do exactly the same thing. All right, so I want to choose 0 because 0 is not being used. And when I choose 0, I'm going to plug it in for x. Okay, so here I have 0 minus 2 quantity squared plus 3. Well, 0 minus 2 is negative 2. Negative 2 quantity squared is going to be negative 2 times negative 2 plus 3. All right, negative 2, positive 4 plus 3 is equal to 7. So y is equal to 7 when x is 0. So I'm going to graph it, go over 0 and up 7. Now I can do, because of the axis of symmetry, I can have another point without doing a whole lot of work. I can look at the axis of symmetry, and 0, 7 is 2 spaces away from the axis of symmetry to the left. So I can go 2 spaces away from the axis of symmetry on the right and find another point. So now that means that 4, 7 is another point of that parabola. So I'm looking and I have 3 points there, and I noticed that 1 is not being used, and so I'm going to plug 1 in because it looks to me like somewhere between 2 and 7, or excuse me, 3 and 7, there's going to be another point. So I'm going to put 1 in for x. All right. And when I do that, I get y equals 1 minus 2 quantity squared plus 3. Well, 1 minus 2 is negative 1. Negative 1 times negative 1 is positive 1. 1 plus 3 is 4. Y equals 4. So let's plot 1, 4. And then I'm also going to plot 3, 4 because it's on the other side of the axis of symmetry, 1 space. All right. So I'm going to draw that parabola. Now, what else can I tell from this parabola? Well, I know that the domain is going to be all real numbers. I know that the range is going to be that y is going to be greater than or equal to 3. And I also know that there are no real roots. Okay, that's enough for vertex form for now. I will do more of it in class when you bring your papers to class. But for right now, we're going to stop and we're going to do what I really wanted to teach you today, which is solving quadratics by factoring. So, oh, I forgot to do this one. Well, I guess we're just not quite there yet. So let's do this problem. I was getting ahead of myself. So again, I want to show you a couple things here. Well, we still know that A is 2, and we know that it's going to be an upward quadratic. But let's look at what the vertex is. Well, we still know H and K, or do we? We have to be very careful here because look at what is in front of the H value. It's a plus sign, but in my equation, I noticed that H has a minus sign in front of it. So that means that my vertex is actually -3, -1. Okay? Because how would I get that to be a plus sign? Well, a negative times a negative. And since I'm subtracting H, and if I had a -3, that means that I would have a minus a -3, which is the same as adding 3. All right. Also, I know that my axis of symmetry is x equal -3. So be careful with that. I do want to show you how to turn it into standard form. And when I do that, notice I have here that quantity squared. So that means that I have x plus 3 times x plus 3. So I have here y equals 2 times x plus 3 times x plus 3 minus 1. Order of operations, okay, say multiply from left to right. Well, they also say exponents and what's inside parentheses. But if you notice here, there really isn't anything to do inside the parentheses. And I've already done my exponent by separating those into 2 binomials, x plus 3, x plus 3. So now I'm going to do multiplication or division from left to right. So multiplication is all I have here. So I'm going to go ahead and distribute that to that first binomial. And when I do that, I end up getting y equals 2x squared plus 6 times x plus 3 minus 1. Now, I'm going to go ahead and FOIL those 2 binomials, but if you want to use a box method, that's fine. I don't care which way you use, but I'm going to use the FOIL by doing my first, outer, inner, and last. Okay, so now I have here y equals 2x squared plus 6x plus 6x plus 18 minus 1. When I do my like terms, okay, I end up with y equals 2x squared plus 12x plus 17. And that's how I would turn vertex form into standard form. Now we're ready to solve by factoring. And again, we're using what we know from last time, last section, and now we're going to solve. What does that mean? Well, let's find out. So the first thing I want you to do to solve is to set the quadratic equal to 0. Well, notice here I have a y. So what does that mean? That means I'm going to replace the y with a 0. Alright, so all I'm going to do is take y away and I'm going to replace it with 0. Now I like to have my quadratic on the left hand side. You don't have to. That's the way I like it. So when I switched my y to 0, I went ahead and I also flipped the sides around. Okay, so now the next thing I need to do is to factor the trinomial. So I'm going to use everything I learned in the last section. So I'm looking at it, there is not a GCF, alright, and I can see here that a is equal to 1, which means that I'm just going to ask myself what two numbers multiply to negative 10 and add up to positive 3. Well, I can see that it's going to be negative 2 and positive 5. So now I can just write my two binomials. The first binomial is going to be x minus 2. My second binomial is going to be x plus 5. That's going to be equaling 0. So remember when we said it was really important for you to understand how to do this? Now you can see why, because we are still using it and you're going to continue using it. So now here's where it changes again. We're going to set each of those factors equal to 0. Alright, that means that I have x minus 2, that's one of my two factors here, and I have x plus 5, that's my second of the two factors. So I'm going to set x minus 2 equaling to 0, and I'm going to set x plus 5 equaling 0. Alright, now I have here, what I want you to do is I'm going to solve each one for x. So how am I going to do that? Well, I'm going to do the x minus 2 equaling 0 first. Alright, I'm going to add 2 to both sides. And when I do that, I end up getting x equals 2. Now I'm going to subtract 5 from both sides. And when I do that, I end up getting x equal negative 5. Alright, so now I'm going to write them in set brackets. And I'm going to write x equals negative 5, 2. Alright, what does that mean? Well, that means that I have found the solution to that quadratic equation. I found the solution, which is another name for roots, which is another name for zeros, which is another name for x-intercepts. So in other words, I have found where the graph of this equation, y equals x squared plus 3x minus 10, passes through the x-axis. It passes through the x-axis at negative 5, 2. So all of the graphing that we've been doing is just to show you what we're actually finding, and that's the roots, the solutions, the zeros, and the x-intercepts. All right, so now let's look at number 9 on your handout. And boys and girls, you may not have enough room to write on this paper. Feel free to use another sheet of paper because it does take a little more space. So let's go through our steps again. The first step was to set the quadratic equal to 0. And I said to replace y with a 0. But there isn't a y there, and it's already equaling 0. So I really didn't have to do that step. It's already been done for me. Okay? So just recognize when there's no y and it's equal to 0, I've already done the first step, which is setting the quadratic equal to 0. Well, what was the next step? The next step I said to do was factor the trinomial. But wait a minute, this is not a trinomial. It's just a binomial. So I'm going to go back to my factoring knowledge. And is there a GCF to pull out? And well, I have x squared minus 8x. So yes, x is a GCF that I can factor out. So if I factor out an x out of both of those terms, I end up with x times the quantity, x minus 8. Don't forget to equal 0. All right, so is there anything else to factor? Well, no, because I have a factor of x and a factor of x minus 8. Okay, so I'm going to set each of those factors equal to 0 and solve. So when I set x equals 0, and my second factor is x minus 8. X minus 8 equaling 0. Okay, and solve. Well, look at this. X is already equaling 0. Easy peasy. I don't have to do any solving. All right. And x minus 8 equals 0. Well, all I have to do is add 8 to both sides. And I end up getting x equal 8. All right. So now I have x equal 0 and 8. I'm putting it in set brackets because it is not an ordered pair. It is the roots, the solutions, the x-intercepts, or the zeros. All right. So now, let's look at 13. Again, I can see that it's already set equal to 0. And again, it's not a trinomial. So I'm looking at it and there's no GCF. But wait a minute. It is a binomial. And the first term is a perfect square. And it is being subtracted. And the last term is a perfect square. So it must be a difference of squares. Well, I know if it's the difference of squares, okay, that I'm going to have x plus 8 and x minus 8. I have two binomials, meaning I have two factors. I have a factor of x plus 8 and I have a factor of x minus 8. They're being multiplied by one another, which was what makes it a factor. All right, so the next thing I'm going to do is I'm going to set each factor equal to 0. And so I have x plus 8 equaling 0 and x minus 8 equaling 0. Okay, so now I'm going to solve for the one on the left by subtracting 8 to both sides, and I end up getting x equal negative 8. And on one on the right, I'm going to add 8 to both sides, getting x equaling 8. All right, so now the answer is, I'm going to show you a fancy schmancy sign. X is equal to plus or minus 8. So that sign with a plus sign and a line under it is a plus minus sign or a positive negative sign. So x is equal to positive negative 8. And once again, what does that mean? That means that the parabola goes through the x-axis at +8 and at -8. So we found the roots, we found the solutions, we have found the x-intercept and the zeros. All right, let's look at 17. So 17 has x squared plus 4x equal 21. Okay, it's not equal to 0, but I can set it equal to 0. How would I do that? Well, I would have to subtract 21 from both sides. All right, so I'm going to move the 21 over to the left side by subtracting 21 from both sides. Be careful. There is no other constant on that left-hand side, so I end up getting x squared plus 4x minus 21 equals 0. And then I would just factor it like normal, okay? I would say, oh, is there a GCF? No, there's not a GCF. So what two numbers multiplied and give me -21 and add up to 4? We're going to finish that one another day. I want to show you one more problem. The next problem I want to show you is number 19. And number 19, again, notice that 7x is not on the left-hand side, so I'm going to move it. But be very careful when you move it, okay, because notice that it is and has an x with it. That means I need to combine my like terms, and I'm going to combine my x's. So when I do that, I end up getting x squared minus 12x minus 64 equals 0. And now I'm ready to factor it. Okay? So what I want you to do for problems 17 through 24, I want you to set each equation equal to 0. I don't want you to factor. I just want to see that you have it in standard form equaling 0. Okay? So don't factor, but just do 17 through 24 and then submit your notes. All right, that's it for now. I will see you another day.